Hello everyone, welcome to the AOS-CX 10.12 update series. I am Shobana, Technical Marketing Engineer, Aruba Campus Switching. In this video, we will see about 10.12 enhancement feature, CDP MIB support for Cisco phone profiling. Let's quickly jump into the session. First, let's see the agenda of this session. So today, we will talk about the overview of this feature, use case it's trying to solve, details and caveats of how the feature works, how to do the configuration and scalability, if there is any issues, how we can troubleshoot it, parity analysis with the competitors, demo of how the feature works, and any additional resources required for this feature. Overview. So let's see the overview of device profiling first. So what is device profiling? So device profiling allows us to gather the device information like what type of device it is, what is the operating system running in the device by inspecting the packets that are sent by these devices in the network. For example, we can identify that a device is a smartphone, is it a printer or a camera using this device profiling information. So who is using this information mainly? So this information is used by the network access control servers to implement the bring your own device flows during the enforcement of profiles. So that is assigning the appropriate privileges and access to the users based on the device type and then the identity of the user. Device profiling protocols. The network access control server perform device profiling by using different types of protocols. So these are the widely used protocols by the network access control servers for device profiling. So these are the ones: DHCP, Radius, HTTP, NetFlow, and then SNMP. Today, our emphasis will be on SNMP, how SNMP based profiling happens, and what is new in AOS-CX switches for the SNMP based profiling. Let's see how device profiling works. We have inclines, access switch, and then the network access control server connected. The ports where the inclines are connected in access switch is been .1x and MAC authentication enabled. So only the authenticated inclines can gain the network access. So when this end device connects to a switch, the switch will send a MAC authentication radius request to the NAC. But the rack does not have any information about the inclines. So it will place the inclines in a quarantine role. So in the quarantine role, the inclines can have only minimal access. So again, when the end device sends any packet like DHCP, LLDP or CDP or HTTP, so that packets will help in the device profiling between the access switch and the NAC. So based on the device profiling protocol type, the device profiling handshake will happen between the access switch and the NAC. So now the NAC will know what type of end device is it based on this device profiling information. After that, the NAC will immediately send the radius change of authorization message for the profile change. So only then the end clients can be correctly placed in the device specific role. So the end device will get deauthenticated because of the radius COA, and again it will try to onboard. So now the access switch will send a MAC authentication radius request, and the NAC currently will know what type of end device is it. So it can easily apply the device specific rule to the end device. So this is how the end devices can be correctly placed in the device specific rule based on the device type. So device profiling handshake plays a major role in identifying what type of end device is it. Use cases. So far we have seen what is device profiling and how device profiling works. Then they may arise a question how it is related to introduction of CDP MIB support in AOS-CX switches. Let's identify that connection using this use case. So in usual campus deployment, we have end clients like voice over IP phones, APs, and then laptops connected using access switch and profiled using network access control servers like ClearPass and Cisco ISC. So the deployment showcased here is needed especially for environment using Cisco ISC and legacy static Cisco IP phones. So these legacy static phones can send only CDP based packets that can help in device profiling. Adding to that, so far with Cisco ISC servers, our switches only support DHCP and SNMP LLDP MIB based device profiling. But both these options are ruled out for these phones profiling. Hence, for such phones, SNMP based profiling using CDP MIB is the only possible solution. So, for that reason, we have introduced CDP MIB in our AOS-CX switches. So, once the CDP packets are received, the CDP MIB is populated in our switches. Later, Cisco ISC will query the CDP MIB for device profiling from our AOS-CX switches based on the configured interval. Finally, it could profile the phone correctly using the CDP MIB response from the AOS-CX switches. So, in conclusion, the CDP MIB support in our switches helps in profiling legacy static Cisco IP phones. Details and caveats. Let's see the details and caveats of this feature. First is the list of read-only objects supported in CDP MIB. So here is the list of CDP MIB objects. So this CDP MIB objects are segregated into three tables. First table is Cisco CDP MIB table. So this MIB table contains information about the running status of the Cisco discovery protocol in the switches. Next is the CDP interface table. This conceptual table contains the status of CDP on the switch interfaces. Next is the CDP cache table. So this abstract table holds the cached information obtained via the received CDP messages. Configuration and scalability. Let's see the configuration first. So to enable the SNMP server on the desired VRF, we have to use the CLI SNMP server VRF and then the VRF name. So this configuration is required for running the SNMP server on the desired VRF. So once SNMP server is running, if we wish to perform SNMP walk on the Cisco CDP MIB, here is the command. So this SNMP walk can be performed using V2 or V3 based on the requirement. So this is the example for the V2 walk. So this is the MIB object for the Cisco CDP MIB. With respect to scalability, currently we support 4 CDP neighbors per interface. Troubleshooting. Let's see how we can troubleshoot if there is any issue with respect to this feature. The foremost thing we need to check is whether the CDP neighbor information is learnt on the interface. For that, we have to use the show command, show CDP neighbor info and then the interface. So this will clearly show whether the CDP neighbor information is learned. So this information is obviously used for the CDP MIB population. So if the CDP MIB information is not turned, we can use the further debugging like diagdem output for the CDP, like diagnostics, diagdem and CDP basic. So this command will show the diagdem output of CDP. So here is a sample output showing the CDP information. Apart from this, it will also show the statistics of the CDP packets received from the interface, thereby helping us to understand whether the CDP packets are really received from the neighbor or not. Next is parity analysis. Let's see whether this feature is being supported in our own products like AOS-S boxes and STC boxes and with our competitors. First with AOS-S switches. So this feature is already supported in that switch. Next is S3C switch. So this feature is not supported in our S3C switches. Next is the Cisco XC boxes. So this feature is already supported in the Cisco switches. Demo. So in this demo, I'll be using the same campus deployment environment and I'll be using a Cisco IP phone 7975 as a static CDP only phone. And I'll be using Cisco ISC as a network access control servers. So in the same way, we will see that Cisco IP phone will be sending CDP packets and using that CDP packets you'll be able to do the SNMP query response for the CDP between the switch and then the network access control server NAC, and how the Cisco IP phone is correctly profiled and then it has been placed in the correct user role. First, let's see the Cisco ISC configuration for the profiling. So let me go to the administration, system and deployment. Here I'll be visiting the profiling configuration tab. For that I have to go to the particular Cisco ISC node and then do a edit. So it will open the node specific page. So then we have to go to the profiling configuration tab and make sure this SNMP based query is enabled. So in the profiling configuration tab, if you scroll down, so here you will be able to see the SNMP query tab. So it clearly says the retrace timeout configuration. So based on the requirement, this can be changed. So these are the default values. So next is profiler configuration. The profiler configuration is the place where we will set what type of COA has to be triggered when there is a profiling change. So for that, go to the profiler settings and select the COA type. So here the COA type I am configured as port bounds. So once the device is profiling, immediately the Cisco ISC node will send a port bound COA. Let's see the network device profile configuration. So I'll go to the administration, system and network device. So here we have to make sure the device details are correct, like IP address and then the radius key and then the SNMP configurations. So once you go to the device view, you can scroll further down to check the SNMP configurations. So what is the SNMP version you'll be using for the SNMP query and what is the SNMP community string. So I'm using the default community string public here. So let's go to the device now. Let's jump into the switch configuration now. So first I will demonstrate how the Cisco phone profiling was happening in 10.11 version, that is prior to 10.12 version. So this version does not contain the enhancement. So you can see show version to identify what is the release in this switch. So I have connected a Cisco IP phone in the port 2/111. So this Cisco IP phone is LLDP disabled and it will be able to send only the CDP based packets. So if you could see show LLDP neighbor, so it does not show the neighbor information, whereas when we see the show CDP neighbor, it shows the neighbor information. So it is a Cisco IP phone 7975 model and it has got the IP address as well. So now let's see how profiling was happening for this Cisco IP phone in the Cisco ISC server. So if you could see here in the endpoint repository page, the device will be now profiled. We'll wait for a minute until it get refreshed. So this is the page where we can see the endpoints. So now the phone has been profiled. Let's see the details about how the phone was profiled. So if you click the phone page and do a edit, you can see the attributes about it. So if you go with the other attributes, you will know what type of information is learned from this device. So if you could see here, the phone is profiled as Cisco IP phone using the DHCP options. So only via the DHCP profiling has happened. So in 10.11 version, the Cisco IP phone was profiled only using the DHCP based profiling. Now let's switch to the 10.12 version. So now the switch is in 10.12 version And if you could see show CDP neighbors, the phone neighborship information is learned. So, and then we will do the SNMP server configuration. We make sure the SNMP server is running in the desired VRF. So I'll be using the default VRF for the connection. So this is the configuration required in the switch. So now let's move to the Cisco ISC. So let's see how the Cisco IP phone is profiled here. So we'll wait for the SNMP query response from the Cisco ISC to the AOS-CX switches. So after that response query, so we could see here the phone is now profiled. So let's see how the phone is profiled in this 10.12 version. So if you could see here in other attributes, the phone is profiled using CDP. So here if you could see here, even though the phone is being profiled using DHCP in the 10 level version, in 10.12 version it is profiled using SNMP query probe. And if you could see here the CDP details. So what are the CDP details gathered from the CDP MIB? So this detail helped us to profile the Cisco IP phone correctly with the specific model. So now I have cleared the endpoint repository. So far we have seen how device profiling worked for Cisco IP phone using Cisco ISC server. So now we will see the actual workflow of device profiling helping the client onboarding. So for that purpose, I'll configure MAC authentication in the IP phone connected port and then associate the radius server group as a Cisco ISC. So I have created two rules. The rule one is quarantine rule that will be used for initial onboarding of the phone. So that rule will contain minimum VNAR access. So here is the rule information. Next, I have created a Cisco IP phone specific rule. That is the rule that will be applied once the phone has been identified as a Cisco IP phone. So here is the rule information. So this is the rule with full access. So now we will move to Cisco ISC and do the configurations here. Similar to configurations in the switch, we have to create two authorization profiles. The authorization profile for the quarantine rule and authorization profile for the Cisco IP phone specific rule. So for that purpose, I am creating first the Cisco IP phone profile. So here I'll try to assign the Cisco IP phone user role I have created in the switch using the Aruba user role VSA. So next I'll be creating a quarantine profile. There I'll be assigning the quarantine rule using the Aruba user role VSA. So here is the profile configuration. So the user role is assigned as a quarantine rule. Next is the policy sets. Policy set is the place where we give the conditions and then the corresponding profile assignment. So here we will have the two conditions. The first condition is profile Cisco IP phones. So it says clearly like only if the endpoint repository contains as profile Cisco IP phone, only then the Cisco IP phone profile will be applied. By default, all other clients will be placed in the quarantine profile. So this is the minimum configurations required in the Cisco ISC. Now let's jump into the switch and then try to toggle the phone connected port. So the phone will get onboarded newly. So initially, as discussed, the phone will first get placed in the quarantine rule because the Cisco ISC does not have any information about the phone. So when we view the command show port access clients interface, particular interface, it will show the client is in quarantine role. So with minimal access. Now the CDP neighbor would have learned and then the SNMP MIB also will be populated. With that information, the phone would have got profiled correctly. So after the phone gets profiled, we will see what is the events happening in the Cisco ISA. If you go to the live logs, you can see it. So first it get placed in the quarantine role. So after that, a port bounce would have happened. And then again the client would have onboarded, and this time the client is getting onboarded in the correct Cisco IP phone profile. So that is how the phone profiling happens, and then the phone gets onboarded in the correct role. Let's see within the details. So I will open the live authentication results here. So here is the authentication result that clearly shows the phone is profiled under the authorization policy. Profile Cisco IP phones. Only when the condition is met as endpoint profile type as Cisco IP phone, this profile will get applied. Let's jump into the switch to check what is the client role assignment now. So we'll go to the switch console and check it. We will issue the command show port access client and then the MAC of the client to check where the client has been placed. If you could see clearly, the client has been placed in the Cisco IP phone role. That is the role specific to the client connected. This is how device profiling helps in onboarding the client in device specific role. So if you face any issues with respect to placing the client in the correct role, we can debug it first in the Cisco ISA. For that purpose, we have to enable debug logging in the profiler. So we'll go to the administration, system logging, and then debug log configuration, and make sure profiler is enabled with debug logging. So only then the debug logging will be present in the logs. To download the logs, you can go to the download logs and ICE node. The debug logs, we can download the recent profiler.log file. It will be downloaded as a zip file. You can extract it and open it in a notepad for further debugging. So let me open it in the notepad. From the logs, we can clearly see the Cisco ISC is performing a get CDP data, that is querying the Cisco CDP MIB from the AOS-CX switches, and then it receives the CDP MIB details from the switch, and it populates the CDP attributes using the Cisco CDP MIB. So if you could see in the attribute section, it clearly shows that the CDP details are fetched from the Cisco CDP MIB of AOS-CX switches. So that's how Cisco ISC could profile the IP phone correctly. So this profiler.log will greatly help in debugging the profiling from Cisco ISC. So we have come to the end of the demo now. Additional resources. Here is the link containing details about the Cisco CDP MIB. You can refer this link for further details about the Cisco CDP MIB objects definition. Thank you everyone for watching this video. If you have any further queries, do reach out to us in our AREDS community. See you all. Bye.